let the minimum value V naught of this expression V equals to mod z square plus z minus 3 square plus z minus 6 iota square, where z is any complex number. This is attained at z equals to z naught. So the minimum value of this expression is V naught, and this expression we are getting when the value of z is z naught. So then the question is, what should be the value of this expression, right? Modulus of square of modulus of this complex number plus V naught square. Now this is a problem on distance formula in complex plane and one interesting property of triangle. Here if you see this expression mod z square plus z minus 3 square plus z minus 6 iota square. Now we know that if I have mod z minus z1, then this is nothing but distance between the complex numbers, distance between the points representing the complex numbers z1 and z2. So if I talk about mod z minus 3, this will be distance between point 30 and the complex number z. Mod z will be distance of the complex number from the origin. And similarly, this third term mod z minus 6 iota, this will be distance of point z from the point 0, 6, right? 6 iota will be represented by 0.06 on y-axis. So basically here, if I take these 3 points, let us say there is one point A representing origin, another point B, and let us say this point is 3, 0. The second term is z minus 3 square, and another point C representing the complex number 6 iota. So the point will be 0, 6. Now let us say P is a point which is representing the complex number Z. So mod Z is nothing but the length PA, right? Mod Z will be PA. Similarly, mod Z minus 3, this will be length PB, and mod Z minus 6 iota, this will be length PC. Now V is nothing but, now you can see that this V will become mod Z is PA, so mod Z square means PA square plus PB square. The second term will be PB square plus PC square. So this is V. Now we know that if we have 3 points A, B, C and P is a point such that PA square plus PB square plus PC square, this is minimum, then that point P is nothing but the centroid of the triangle, right? So that means here V will become minimum if P is the centroid of this triangle, and from there we can get the value of Z naught, right? So these are the 3 vertices A, B, C. So therefore Z naught must be Z1 plus Z2 plus Z3 by 3. That is the standard formula for finding the centroid. So this divided by 3, that will be the centroid Z naught. Now here if you add these 3 numbers, 0 plus 3 plus 0 divided by 3, so that will give us 1. And uh, 0 plus 0 plus 6 divided by 3, so that will give us 2 iota. So this is the complex number Z naught. Now this is standard result that you can remember, that PA square plus PB square plus PC square, that is minimum if P is centroid. There is another way of solving this problem also. In place of Z naught, you can write, in place of Z, you can write x plus iota y. And using a square completion method also, you can find the least value of this one. That means in place of Z, if we write x plus iota y, then that given expression V, this will become Z square means x square plus y square. Mod Z minus 3 square means x minus 3 square plus y square. And mod Z minus 6 iota square, so that means x square plus y minus 6 square. This is the expression for V. And now you can make perfect square. I mean, you can take 3 common from x square term. So you will get x square. And from here you will get 2x. For creating perfect square, you can do plus 1 minus 1. And similarly, from y term, you can take again 3 common. So you'll get y square minus 12y. But we have taken 3 common. So minus 4y. For creating perfect square, plus 4 minus 4. And plus from here you will get 9, and 9 plus 36, so that will give us 45. So this is the expression for V. And now using a square completion, you can write this as x minus 1 square, first 3 terms, x square minus 2x plus 1. Similarly, 3 times y minus 2 square. And then the constant term will be minus 12 minus 3. So minus 15, 45 minus 15. So that will be 30. So this is the expression for v. Now again you can see that these two terms, they are perfect square. So they will be either positive or 0. Right? They cannot be negative because x and y are real numbers. So if this term is always greater than equal to 0, similarly this term is also always non-negative, then clearly you can see that minimum value of this function v or v naught, this is nothing but 30. And the point where this will become minimum, this is um, if I make x minus 1 0, then x will be 1 and y will be 2. So that means z naught is nothing but 1 plus 2 iota. So using this approach also you can get the value of z naught. But if you are familiar with this result that the point is centroid of the triangle, then directly you can see that z naught will be 1 plus 2 iota. So now v naught is 30, z naught is 1 plus 2 iota. And we need to find the value of this expression. Now here in place of z naught, you can substitute 1 plus 2 iota, and let us call this complex number as some complex number omega. So in place of z naught, when you substitute 1 plus 2 iota, you will find that omega will become 8 plus 6 iota. Right? Replace z naught with 1 plus 2 iota because z naught will be the centroid of the triangle, or using a square completion method. In place of z naught, we can write 1 plus 2 iota. And after simplification, you will get this complex number omega as 8 plus 6 iota. Now the question is, what is the value of this expression? V naught we have obtained earlier. V naught was 30. And if omega is 8 plus 6 iota, then this is modulus of omega square. So 8 square plus 6 square, that will be 100 plus another 30 square, which will give us 1000. So the correct answer for this problem will be first option. Right, so this was a problem where if you are familiar with this result that the point will be centroid, then directly you can see z naught and from there you can get v naught. Otherwise, in place of z, you can write x plus iota y and then you can create perfect square. And perfect squares are never negative. It will be either positive or 0 because x and y are real numbers. So least value of v, that is v naught, that will be 30 and z naught is 1 plus 2 iota. Substitute the value of z naught here and you will find that this complex number omega will be 8 plus 6 iota, and therefore the value of this expression will be 1000, and hence the correct answer for this problem is first option.